Hello, so in this video we are going to solve question number 5 of GATE 2018 physics paper. The question is from mathematical physics section. The question is the scale factors corresponding to the covalent metric tensor Gij in spherical polar coordinates are. Therefore, in this question we have been asked what are the scale factors. So if we just write, for example, in a Cartesian coordinate system, we know that line element dl can be written as dr, dx x cap dy y cap plus dz z cap, where x, y, and z are three independent bases of this Euclidean 3D geometry. Therefore, in the same way, they have asked us what are the values of this dx, dy, dz corresponding to dx, dy, dz. What is the value of the scale factors in the spherical polar coordinate system? Therefore, first of all, we'll do the transformation from Cartesian coordinate system to spherical coordinate system, polar coordinate system. We know in Cartesian coordinate, the basis vectors are I, j, and k cap, three different directions, x, y, and z. Similarly, in spherical polar coordinate system, the basis vectors are r cap, theta cap, phi cap. So these are basically the three different basis vectors which are used to prescribe any spherical polar coordinate system. So if we just want to do the transformation from Cartesian coordinate to spherical polar coordinate, so let me first draw the Cartesian coordinate system, x, y, and z, three directions mutually orthogonal to each other. Suppose you have a point P in this Cartesian coordinate system, some x, y, and z, and in polar coordinate system, spherical polar coordinate system, it is a distance r. So the position vector is r of this point P. And similarly, if we take the projection of this vector in xy plane, then this angle which is made is called phi. This is theta. Okay, so if we just see, then your z transformation, your z will be nothing but, from this equation, your z will be nothing but r times cos theta. X will be since this is z is r cos theta, therefore this is r sin theta. Therefore x is r sin theta times cos phi. Okay, because this is r sin theta and hence this is r sin theta cos phi. Similarly, y will be r sin theta sin phi. Okay, so we have got these three equations which we may call as 1, and this position vector r is nothing but x square plus y square plus z square 2. Now we can write any position vector r as rx times x cap in 3D geometry, Cartesian coordinates, y cap plus rz times z cap. Now we can just use this transformation. We know that rx is nothing but r sin theta cos phi x cap, ry is r sin theta sin phi, y cap, and z is r cos theta, k cap. This is 2. Now we just take derivative of this del r by, with respect to all the 3 independent bases. First of all, del r vector by del r. So it will be sin theta cos phi x cap plus sin theta sin phi y cap plus cos theta z cap. So, and now we'll just take the magnitude of this quantity, which is nothing but square of under root of the square of all the components, these 3. So it will be sin square theta cos square phi plus sin square theta sin square phi plus cos square theta to the power 1 by 2. Take sin square theta common, you're left with cos square phi plus sin square phi plus cos square theta to the power 1 by 2. This is 1, so what we are left with is sin square theta plus cos square theta to the power 1 by 2, which is 1 to the power 1 by 2, which is equal to 1. So del r by del r magnitude is 1. Similarly, we will also calculate del r by del theta, which will be r cos theta cos phi x cap plus r cos theta sin phi y cap minus of r sin theta k cap. Similarly, we'll take also the magnitude of this. So we'll get r square cos square theta cos square phi plus r square cos square theta sin square phi plus r square sin square theta to the power 1 by 2. Just take common, you can just take common r square cos square theta, you just take common r square cos square theta, then you're left with cos square phi plus sin square phi plus r square sin square theta. This quantity is 1, so you're left with r square sin square theta plus r square cos square theta to the power 1 by 2. Take r common, you are left with r. In bracket you will get sin square theta plus cos square theta, which is 1. So this is 2. Similarly, you can also find del r by del phi magnitude. What you will get is, in this case, r sin theta. I'm just writing the answer. Similar calculation. Therefore, the line element in spherical polar coordinate system can be written as ar r cap plus a theta theta cap plus a phi phi cap, or we can write this as dr r cap theta cap, sorry, this will be r phi cap, and which we have already calculated. It comes out to be, this is 1 times r cap plus r d theta theta cap plus r sine theta d phi cap. So the scale factors are these coefficients, which is 1 comma r sine theta. This will be the answer. Also, we can also solve it in another way using the metric tensor form. We know that square of the line element dl square is given by g11 dx1 whole square plus g22 dx2 whole square plus g33 dx3 whole square, so on and so forth. Now in our case, these dx, dx2, dx3 are different dimension, different basis vector. So this gij is what they have given in the question, is called coherent metric tensor gij, and the element of this coherent metric tensor is g11 0 g22 0 0 g33, and this will continue up to g last term. Okay, now in our case we don't have this in our case, since we have r theta phi, and our line element we have already calculated comes out to be so the scale factors are just the square root of this element of this coherent metric tensor. So in our case, the element of the coherent metric tensor is just square it, so it will be 1 0 0. Just use this 0 r square 0 and 0 0 r square sine square theta. So these are the elements of this diagonal elements of this coherent metric tensor corresponding to r theta and phi cap. Therefore the scale factors will be just the under root of this, which will be just 1 r sine theta. So the correct option is D. Thank you for watching this video.